afternoon, ladies and gentlemen. My name is Dr. Jon Belkowitz, and it's Q&A day. And we've got a question from Ding Joe
Debucci.
And thank you, Joe,
Debucci.
for sending us a question. Now, Joe,
Debucci.
it's very important that we answer your question. And Joe,
Debucci. Debucci.
I don't want to shortchange you at all. So, Joe,
Debucci.
here we go. Ding! Joe,
Debucci.
would you be able to dive into the whole process of soaking RCA in colloidal silica? What occurs to the RCA to make it less absorptive material? Does the colloidal silica affect not only the properties of the aggregate but also the concrete? If so, how? Joe, love this question, and this one, I would like this one to go out as soon as possible, and I want the entire team to flip and share this. Ooh, I almost cussed. Joe,
Debucci.
I almost cussed. So let's get into it, Joe.
Debucci.
So what is the process? Question number one, what is the process of soaking RCA in colloidal silica? Now, Joe,
Debucci.
I don't know if you're working in a ready-mix plant or if you got a, small precast architectural cast stone, in a warehouse behind, whatever. So let's just assume that you're putting this into a mixer. And it's really easy. What you want to do is take your recycled concrete aggregate, whether it's coarse or fine aggregate, and you want to take a small percentage of your headwater. You can take all of it too, but it's a little bit better if you take around 25 to 35% of your headwater, mix it up with your colloidal silica, anywhere from 2 to 20 ounces per hundredweight, and give it a 30 to 60, I sound like I tooted, 30 to 60 second spin in your central plant mixer, in your truck, in your lab mixer, in your plant mixer, whatever your mixer is. You want to mix up your water with the colloidal silica in it with your RCA for that 30 to 60 seconds to get that pre-soak. You don't have to let it sit there for 30 to 60 seconds afterwards. Once you mix it for 30 to 60 seconds, you're good. And what we want to do, question number two, what occurs to the RCA to make it a less absorptive material? Listen, it's going to be an absorptive material. You're not going to change it. What you're going to use that absorption to your benefit. So the first thing that happens is you have a lot of water throughout the mix, or throughout your recycled concrete aggregate, coarse aggregate, or sand, or your fine aggregate. So you're going to mix that up with the water and the colloidal silica, and what you're going to see is an initial reaction of the absorption, especially if it's drier material. If it's not drier material, you can use less water, but you're going to have this diffusion of the colloidal silica through the surface and the subsurface of your aggregate, and it immediately will start reacting with the soluble alkalis from the cement, from the salts that are in the concrete and the aggregate, and create a gel around that surface, almost like a hard candy shell, but it's not hard, it's more of like a hydrogel, if you will. And that does two things. One, it clogs up those pores that would cause monopolization of water and paste from the concrete, or from the fresh concrete. The second thing that it does is, when it's hydrating in the concrete, we have some water in this pore of our recycled concrete aggregate, both coarse and fine, and that pore, that hydrogel, will effectively manipulate the molecular kinetics of cement hydration at longer ages in a similar manner to internally cured concrete when we use expanded shell and we pre-soak the expanded shell to have water at that interfacial zone. So it's really going to enhance the interfacial zone. So does the colloidal silica affect not only the properties of the aggregate but also the concrete? If so, why? Yes, Whitney has done some research with her university. Mallory is pushing that through publication right now, and it shows that when mixing the colloidal silica, or pre-soaking the colloidal silica into the recycled concrete aggregate, what you're doing is not only affecting the interfacial zone, but you're also affecting the mechanical properties, specifically your shrinkage, your strength, and of course your fresh properties. We see a longer slump evolution and just better stabilization of the mix compared to when we don't have a pre-soak, when we use a pre-soak with just water, and then the different types of colloidal silica that we use throughout that project. So Hopefully that answered your question, Joe.
Djibouti.
Thanks again. Don't forget to like and subscribe, Joe.
Djibouti.
Have an awesome one. Go Concrete!
Beat asphalt.
Joe!
Djibouti.